Hey guys, the Wood Craftsman here. In this video I'm going to be going over this exhaust wall that I built here over the last couple of weeks. This is a huge improvement over the shop and I can't wait to actually start using it. This setup is capable of pulling out about 3,600 CFMs at my current arrangement right now. My previous exhaust fan was a Dayton panel mount axial fan. It actually had an explosion proof motor on it. It was a class 1 group D Balder. I actually had a 1/2 horse motor on it. The fan itself only required a 1/4 horse, but I went oversized to keep the motor cool and for the most part worked really well. This setup is quite a bit different. I've got a much larger filter area. This filter area is actually a little bit bigger than a 4 foot by 7 foot spray booth or exhaust wall. This is actually 4 feet wide by 6.5 feet high. You might be wondering, well, how do you have more filter area? If you look at a 4 foot wide by 7 foot high spray booth, they use 20-inch filter grids or filter panels. And on a 4 foot wide, they're only 20 inches and 20 inches, which is 40 inches. And then they're basically 4 high, which is 80 inches. So basically they have a 40 by 80 filter area versus this one here has got a full 48 inches by I'm a little bit under 72 inches. I'm actually about 71 inches approximately. So the filter area is a little bit larger. Not much. It's not a lot to brag about, but it's just one of those things that it is a little bit bigger. And the CFMs on a 4 foot by 7 foot high exhaust wall is about 3,500 CFMs. This one's about 36. So I'm a little bit bigger, which is kind of a nice thing. The disadvantage is that my intake fan was actually sized to match my old exhaust fan. And so for the simple reason that old exhaust or the old intake fan was only capable of putting in about 2,800 CFMs. And this one actually pulling out 36. I had to come up with another 800 CFMs roughly to maintain that. So I actually added another 12-inch panel fan, just like the 16-inch one that's pushing in, just a smaller model because I already had a hole in the wall from a previous setup. So that actually turned out really well. So now the fan can run at a full 60 hertz on a VFD and the intake fans run at about 58 hertz. So I have a little bit more air to push. However, I did try speeding the fan up some more and I was actually still lacking a little bit of air. So right now about 3,600 CFMs is what I'm able to get out of this. So this was a huge improvement. There's one other update I'm going to do to this one yet, and we'll walk over to the bench and talk about that one. But this overall setup is a huge improvement. So I'm really looking forward to use this. I don't have anything to spray right now, so I'll be sure that on anything that's coming up to be sprayed, I'll be sure to set the camera up, do a little bit of capturing of it. But I'm really excited about it. The other thing I did too was add a Dwyer manometer. This is a Model 25 Mark II or Mark II Model 25. This is designed to basically monitor your filter loading. As the filters load up with overspray, the static pressure increases. So right now when this fan is running, it's at about 10, I believe, 0.10. And ideally they say, I think it go up to like 0.4 over. So be running at about 0.5, which is the max filter loading. I have to do a little bit of research on that. There's a lot of things to take in consideration, but my my clean filter operating mode is at 0.10. So this is a real simple setup, and I could have left it as is like that. Other than the fact is I did have to add a second intake fan to make up for the air loss. This is a simple reason that anytime you open up a door, it'd suck the door open. Right now, it's basically the doors will close on their own with the spring-loaded hinges that they have on for fire code. So I'm going to go and show you another thing I want to add to this setup, and then I'll actually run the spray exhaust wall up here at the end of the video. Okay, so we're back at the workbench here, and the one thing I wanted to do to improve this system, especially because I've got two dissimilar fans pushing air in and drawing the air out, to maintain a positive air pressure in the room is going to be very critical, but I want to make sure that I don't overdo it, especially based off of filter loading and the other conditions such as an open door, things like that. A company called JBI, which is now called Global Finishing Systems, they make spray booths and downdraft booths and automotive booths and all sorts of different spray booths. They have an option where you can buy a control panel that'll actually replace the manometer on your spray booth with what they call a photohelic. And I actually have one right here. So this gauge here pretty much resembles the same thing on the that I have back here, such as the manometer. They're both made by Dwyer. This one, however, is a lot more sophisticated. It's actually got some electronic smarts to it. Now this dial face, you can get this by itself. They call it a magnahelic, and it's the same type of thing. It's a way of monitoring positive or negative air pressure. The photohelic on the other side is basically there's a couple of photo eyes inside here that read off an LED light, to my understanding, and how the needle moves, the black one, basically sends a signal to whatever you're trying to control. In this case here, what JBI and Global Finishing Systems was doing is they actually have their exhaust fan motor driven by a variable frequency driver, VFD. And the fan size might be a little bit oversized. And what happened is when you start with clean filters, the fan would run at a lower RPM. And as the filters were to load up, the fan would gradually keep on increasing depending on what the static pressure was. And they would do that with this system right here. There's 3 needles. There's a black needle, which actually is your real-time display as far as what your air pressure is doing. And then the red needles is a positive and negative, so you can have it sit out so to maintain a specific pressure range. What would happen there is, as I mentioned, as the filters would load up, the fan would speed up, and then once you get to a certain point, you'd have to replace the filters again. You can do that on the other side of things as well. You can do that with your incoming air. A friend of mine who worked for a cabinet company up in the northwestern part of the state, it was a smaller shop. I would say it was probably maybe 4,000 square feet maybe, and they actually had their own finishing room that was probably about a third of that. They actually had an outdoor air makeup unit. It was actually an indirect fired versus a direct fired. And that air makeup motor was actually on a VFD, and they actually used a Dwyer photohelic to actually maintain a specific room pressure. So if anybody were to open up a door in the finish room, basically that VFD would make that air makeup motor speed up a little bit to maintain a specific airflow and not take from the path of least resistance, which might be the open door, so you wouldn't suck any dust in. And that air makeup motor would speed up or slow down based on a lot of different conditions as far as what the room pressure change was. So that's what I'm going to be doing with this as well. I'm going to be doing the exact same thing. I'm going to be monitoring the room pressure and maintaining a specific pressure inside the room. Now, normally it's not a huge concern, but I actually have a central heating and air conditioning system in the shop here, and what I don't want to do is have too much incoming air and push the stinchy air backwards through the ventilation system in the shop here, and just basically just move the nasty air around. So ideally it'd be nice if I was drawing out 3,500 CFMs, I'd be pushing in 3,500 CFMs, and this will help do that, but there's still going to be a slight variation. But basically it'll help ensure that I'll always have a specific airflow or positive pressure in the shop. Even as the filter loads up and I see that the manometer is rising, maybe it's getting to that 0.3, so technically it's probably drawing out a little bit less air, so I should be putting a little bit less air coming into the shop. So it's probably a lot, it definitely is overkill for a lot of situations, but for here, this is definitely something that is a very minimal investment. I paid 30 bucks for this off of eBay plus $8.95 shipping and handling. If it works, it's great. If it doesn't work, it's 40 bucks. And I know it's money, don't get me wrong, but it'd be a whole lot different if I would have spent, say, a couple $100 on this and the idea didn't work and I couldn't return it. So it was a minimal investment, and I'm always willing to try something with a minimal investment. So it is definitely something that can be done. I just need to work with a friend of mine who's an electrical engineer to help get this wired in and figure out the best place as far as how to mount it and how I need to measure the static pressure inside the shop. But essentially there's the 2 ports right here, just like on a manometer. It does the exact same thing. So If you didn't want to, if you were building your own exhaust well or spray booth, you can use that cheap Dwyer, which is not really cheap. It's actually kind of expensive. I got that one there for about 40 bucks. But you can actually use what they call a magnet helix, which is the same thing as this, but it doesn't have the electronics in the back. It's just a gauge. And you can use that as well to monitor your static pressure on your filter bank. It just really depends on what you want to do. So that's kind of it, what I've got going on with this here. I'm going to go and set the camera up and start the exhaust wall up for you. But that's kind of the project I got going on right now. So right now, as is, it will work just fine. But if I want an improvement, I'll actually be adding the photo helix. So that'll be my next step yet. Other than that, that's pretty much it for this video. All right, guys. Hope you guys enjoyed the video. Questions and positive comments are welcome. Thanks for watching.